So this is just a video explaining how an ellipse is formed through concentric circles. So if we just look at the image here in the corner, this is what we'd all be used to growing up in school. We can see the minor axis here and the major axis across here, and we'd always be told bring wherever it hits the minor circle, which you can just about see here, bring it parallel to the major axis, and vice versa where it hits the major circle. And we went off and learned that by rote and applied it everywhere. But there comes a time when that won't work. When, like we can see here, how the ellipse is actually slanted at a curve, or sorry, it's on a slant. So our x and y axis are gone out the window. There's no up and down, left and right. Everything is sloped. So this is where we actually have to know the principle of how it's formed. So we need to know that wherever along the minor circle that one of our rays will cut, we need to bring it parallel to the major axis rather than just across to the left or across to the right. And vice versa, where the ray hits the major axis, we can't just bring it up and down, we have to bring it parallel to the minor axis. So if we have a look here at this GeoGebra video, it will show us how this works. So as we can see here, it's tracing in an ellipse as we rotate this ray around. So just to make it a small bit more clear, I'm going to draw in two line segments from point B to point D, and also from point D to point C. So if we just start this again, we grab point B, which is representing our ray, which are typically brought out at 30, 60 degrees or 45 degrees for the sake of ease. If we rotate that around, we can see here, if we rotate that around, we can see how it draws the ellipse slowly through the point D. Line DC is always parallel to GF, which is representing the major axis, and point BD is always going to be parallel to the minor axis. So as we rotate this ray around, the dynamic model will draw for us the ellipse. So as we see here, no matter where on this circle we place the ray BA, we will always get point D. So as we bring it around, it will always draw a perfect ellipse. The only 2 points on the ellipse where we won't have point BD, we will see it as a point, and that's along the major axis, as we can see now, and vice versa for the minor axis. We won't see point C or line CD because they will be a point as they are perfectly horizontal.